Hi, good evening, students. This is Deepanshu Agrawal. Welcome to Mindworks. This video in continuation with the series that we have done on the live assessment. So, in this video series, generally, you'll have around 5 6 questions. A short assessment type of questions would be there, or series would be there. So you'll have around 5 6 questions. As you can see on the screen, there are 6 questions, and you would be getting exactly 12 minutes to solve these 6 questions. Okay, right. After that, I'll give you the answers of these questions, and then I'll also give you the solutions of these 6 questions, right? So you would be getting exactly 12 minutes starting from 11 to it's 11 to as of now. So from 11 to 11:14, exactly 12 minutes. 6 question, 12 minutes. You should start now. If you can't see the 6 question, let me make it visible. Yeah. Okay. So those who have just joined, 6 questions and 12 minutes. After that, solutions and the answers would be discussed. Yeah. I hope you have your copy and pen with you. Those who would be watching the video as a recording, so they also should not pause the time, or they should also not interrupt between the video. They should play the video in the normal speed and try to stick to the timer that has been given to solve these 6 questions. Okay. Yeah, please go for it. 2 minutes are already gone. Let me remind you. Please start very quickly. Those who have just joined, this is a live assessment session. 6 questions are there. 12 minutes would be given. After that, answers and solutions would be discussed. So please start the questions as soon as possible. Go for it. Those who have just joined, live assessment series is going on. Short assessment is there, and 6 questions, 12 minutes would be the stipulated time, out of which 5 minutes are gone. So we are only left with 7 more minutes. If you are preparing for any MBA entrance exam, you should be really, really quick. In those 12 minutes, you should be able to do at least 4 questions. Okay, 4 questions correct. At least 4 questions correct, you should be able to do. Those who have just joined this live session, we have 6 questions on the screen, and I had given 12 minutes to complete these 6 questions, out of which 7 minutes are already gone. So we are left with only 5 minutes. Only 4 minutes remaining, students. If you're taking this as a proper assessment test, then you should be able to do at least 4 questions correct. Last 2 minutes, students. Last minute, student. Only one more minute. I think the time is up, students. So I feel that we should start solving these questions. Let me give you the answers first. Okay, then we'll try to solve the questions. Okay, so the answer for question number one is 4. Yeah, the answer for question number one is 4. The answer for question number two is 111. The answer for question number three is 2. Answer for question number 4 is 364. Yeah, 364. The answer for question number 5 is just a second. 21. And the answer for question number 6 is 35. These are the answers, right? Now you can assess yourself. If you have got at least 4 answers correct, then you should be you can consider yourself on the right track of your preparations. Okay, but if less than 4 are correct, then you need to work harder. You need to work more efficiently. You need to change the method of how you study. Okay, and you should try to get the guidance from somewhere. Okay, so question number one, it says let n be the greatest number which will divide 1305, 4665, and 6905, leaving the same remainder in each case. That means 1305 minus the remainder, right? 4665 minus the remainder, and 6905 minus the remainder. All these numbers should be divisible by n. N should be able to divide this number, this number and this number, because when 1305 is divided by n, remainder is r. When 4665 is divided by n, the remainder is r. When 6905 is divided by n, the remainder is r. So we have to find the greatest value r can have. No, n can have. The greatest value n can have. Okay. So if suppose a, b, c all are divisible by n, right? So you should be knowing a property that if a, b, c all are divisible by n, then their difference would also be divisible by n. I mean, b minus a and c minus b will also be divisible by n. Right? Let's take an example. Suppose 30, 42 and 54 all are divisible by 6. So you'll find the difference will always be divisible by 6. For example, 42 minus 30 will always be divisible by 6. 54 minus 30 will always be divisible by 6. So whenever three numbers are divisible by 6, whenever three numbers are divisible by a certain number, then their difference is also divisible by that number. So this is what we will use. Why we are using this property? We are using this property so that so as to eliminate the value of r. Okay, if I take the difference of the second and first, and I take the difference of the third and second, so we will be able to eliminate the value of r. We will be able to eliminate the term r. So 4665 minus 1305 will give you 3360. Okay, and 6905 minus 4665 will give you 2240. Right? So the number n, the number 3360 and 2240 both are divisible by n. According to the situation, both numbers are divisible by n. Right? So if both numbers are divisible by n, so that means their the HCF, the common multiple of both these numbers would be the value of n, would be the highest value of n. Right? If n is the common factor of both the numbers, and n has to be the greatest. N is the common factor of both the numbers, and n has to be the greatest. So what does it mean? It has to be the highest common factor of 3360 and 2240. Correct? So highest common factor of n would be 1120. So the greatest value of n will be 1120. Now we have to finally give the sum of the digits in n. So sum of the digits in n is 4. This is the first question done. Okay. Second one. So second one is the product of the two numbers is 4107. If the HCF of these numbers is 36, then the greater number is. Okay. So remember, when two numbers are given, A and B, and their HCF is given as H, H is the HCF of A and B, so they can be resolved in H into P and H into Q. Right? If H is the HCF of A and B, then A and B can be resolved in HP and HQ. Correct? Now it is given that the product of the two numbers is 4107. So that means HP into HQ will be equal to 4107. Now we will put the value of H as 37. Right? H, the H is the HCF, and we have been given that the HCF of these two numbers is 37. So you will put the value of H. So it means 37 square into PQ will give you 4107. Correct? 37 square into PQ will give you 4107. Right? From here, you'll get the value of P into Q as 3. Okay. So 37 square would be, when you divide 4107 twice from 37, so you'll get the value of P into Q as 3. Okay. You can do it, uh, if you are watching a recording, then you can pause it and you can solve it, right? I have solved this question before, so I know it, that you are going to get the value of P into Q as 3. So if two numbers has the multiplication equal to 3, then the number can only be 1 and 3, right? Two numbers which have their multiplication as 3 are 1 and 3. That's it. So the one of the value has to be 1 and the other value has to be 3. So either P is 1 and Q is 3, or vice versa, whatever it is, right? There is nothing to take in order. Okay, so we have to find the greater number. So greater number has to be h into 3, means 37 into 3. So 37 into 3 will give you 111, this one. So here we have solved question number 2 also. Okay, right. Let's go for the next one. See, I am a little bit fast because you will anyway would be watching this as a recording. So I'm being fast. If you are not able to understand, if you are live, if you are currently attending live and you are not able to understand, so you will have the option of watching the recording anytime you want, and the audience who's going to be watching it live will will be able to pause, repeat, and rewind the section which you are not able to understand again and again. Okay, so almost the same question as question number 3. In this question also, same thing has to be done. The product of two numbers is 2028, HCF is 13, and we have to find the number of such pair. So in question number 2, we have to find we had to find the greatest number. In question number 3, we have to find the number of such pair. Okay, so the product of two numbers is 2028. That means HP into HQ. HP into HQ is equal to 2028. Now put the value of H as 13. So this will give you 13 square into PQ equal to 2028. So you'll get 13 square as 169, and 2028 divided by 169, you'll get P into Q equal to 12. Okay. This is something that you need to do yourself. 2028 divided by 169. Okay. So P into Q would be equal to 12. So how many pairs are there? How many pairs are there which can follow this pattern, that this which can satisfy this equation P into Q equal to 12? So the first pair is 1 into 12. The second pair is 2 into 6, and the third pair is 3 into 4. But remember, whenever P and Q is being taken, so this P and Q are the residue numbers after taking out the highest common factor. So P and Q cannot have further common factor. Okay, because P and Q, whatever the common factor in the complete number was there, has been taken in the highest common factor. So P and Q are the numbers which are left after extracting all possible common factors. So therefore, P and Q doesn't have any common factor. P and Q cannot have any common factor. So we will discard this second one because 2 into 6 actually has a common factor. So 2 into 6 would be discarded. We would be left with only two solutions. So that's your answer. The number of such pairs is 2. That's your answer. Okay. Question number 4. This was question number 3. Let's go to question number 4. Question number 4 says least multiple of 7, which leaves a remainder 4 when divided by all these numbers, right? So for now, for to start with the question, first forget the initial line, least multiple of 7. Just focus on this. A number which leaves a remainder of 4 when divided by all these numbers, right? So a number when divided by 6 leaves a remainder 4, when divided by 9 leaves a remainder 4, when divided by 15 leaves a remainder 4, when divided by 18 leaves a remainder 4. This is the case, right? So can I say that if I subtract 4 from that number, if I subtract 4 from that number, so that would be a common multiple of 6, 9, 15, and 18. Can I say that? Obviously, yes. So n minus 4 should be a common multiple of 6, 9, 15, and 18, right? So now, first of all, we have to calculate the common multiple of 6, 9, 15, and 18. So the first common multiple, or I should say the least common multiple of 6, 9, 15, and 18 would be 90. Okay. I hope you know how to calculate the LCM or the HCF of the four numbers that has been given, right? So I am expecting that you know how to quickly calculate the LCM of four numbers. So the LCM will come as 90, as you can see. So n minus 4 is 90. This is the equation. This is the new equation. N minus 4 should be equal to 90, right? So therefore, n should be equal to 94. Okay. So the first number following such property would be 94. But what if I increase this common multiple to the second smallest common multiple? If I, instead of 90, I put 180, so then the second number would come as 184. Second such number, which when divided by 6, 9, 15, and 18 leaves a remainder 4, will be 184. Right, first number was 94, second number is 184, third number is 274, and the fourth number would be 364, and so on. It will continue progressing. 454 would be the next number, and so on. Okay, so we have to also determine that number which is the least multiple of 7, which is the least multiple of 7, right? Now we will reveal the first condition, that the number has to be least multiple of 7. So is 94 a multiple of 7? No. Is 184 a multiple of 7? No. Is 274 a multiple of 7? No. Then you will find that 364 is a multiple of 7. So the least multiple of 7, which leaves a remainder 4 when divided by all these numbers, is 364. This is how this question would be solved. Done? Right. I hope this is done. We're moving to the question number 5. Okay. Question number 5 says, a rectangular courtyard 3.78 meters long and 5.25 meters wide is to be paved with the square tiles of exactly same size. What is the largest size of the tile which can be used for the purpose? Right. So first of all, change this. Let's understand this with a simpler value, with a very smaller value. Okay. Suppose this is 24 and this is 15. Right. This is a rectangular room which has length 24 and breadth 15. So if I want to fill this complete ground, this complete floor with these square tiles, with these square tiles, so how will these be filled? So if I take a square tile of 1 cross 1, 1 cross 1, so this would be filled completely and this would be filled completely, right? But there would be 15 into 24, that is 360 square tiles, right? So we have to find the largest size of the tile which can be used for the purpose, right? So can we use the square tiles of 2 cross 2? Can we have the square tiles of 2 cross 2? No, because 2 cross 2 will fill this line but will not be able to fill this line because 15 is not divisible by 2. Correct? Can we have the square tile of 3 cross 3? Can we have the square tile of 3 cross 3? Yes. When we have the square tile of 3 cross 3, this would be filled completely and this would also be filled completely, right? So all these valid numbers, 1, 3, all these numbers are actually the common factors of 15 and 24. Obviously, if you have the common factor of 15 and 24, then only you will be able to fill the breadth and the length of a rectangle perfectly with those square tiles only, right? So, uh, and if we want that common factor, if we want that common factor to be largest, so that has to be the HCF of 15 and 24. What is the HCF of 15 and 24? 3. So we will have 3 as the largest tile size which can be used to fill, to pave this rectangular floor. Okay, so that's exactly what you need to do in the question number 5 as well. In the question number 5, because you're not able to get this question because of the language, so I have explained a similar question with a simpler value. But in question number 5 also, you just have to take the HCF, highest common factor of 3.78 and 5.25. Convert this into the meter, into the centimeter, make it 378 and 525, and just take the HCF of these two numbers. Okay, you'll get the answer as 21. You'll get the answer as 21. Okay, next one, last one. The greatest possible length which can be used to measure the length exactly 7 meter. We can write 700 centimeter. 3 meter 85 centimeter, we can write 385 centimeter, and 1295 centimeter, right? So greatest possible length which can be used to measure all these three. So suppose I take a scale of 1 centimeter. So obviously I can measure 700, I can measure 385, and I can measure 1295, obviously. Okay. Can we have a bigger number? Can we have a 2 centimeter scale to measure all these three? No, because by using this 2 centimeter scale, you will not be able to measure 385. 385 is not the multiple of 2. Okay. Can we have it as 3? So 3 can be used to measure 700? No. 3 cannot be used to measure 700. Whatever the number we are writing here should be a multiple of all three number. Should be a factor of all three number. Okay. Then only we will be able to measure all the three lengths by this number. And if this number that we are talking about has to be the factor, has to be the common factor of all these three numbers, and it also has to be the greatest, it also has to be the greatest, So it is also a question of a simple question of HCF. You just need to take the HCF of 700, 385, and 1295. Okay. It may look easy, students. This question may look easy to you, but when you see this question in the exam, na, so you'll not be able to detect that this question is of HCF and LCM. Right now, you have the topic as HCF and LCM only. So as you can see, you the first thing that comes to your mind would be HCF and LCM only. So that's why you are able to detect it. But if you are attempting the same question in any of the MBA entrance exam, any of the entrance exam, so then you will not be able to guess this that this is a question of HCF only. Okay. Once you are able to figure out that this is the question of HCF only, then there is nothing in this question. You just need to calculate the HCF only. Okay. But it would be difficult for you to judge whether this question is of HCF LCM or not. Okay. So that would be all from my side in this video, students, in this live assessment. So let's meet after maybe 4 5 days, right? I'll notify you before coming live, and in the next session we'll take another chapter. Okay, HCF LCM number system is done, so we'll take another chapter, and that would be surprise. Obviously, the name of the chapter is not revealed, right? Because this has to be a spontaneous test. This has to be a surprise type of test, right? Because uh, revealing the topic will not make this assessment so efficient. Okay. All right. So students, that would be all from my side. Thank you for joining. Bye bye. Take care. Thank you.